So today I'll be talking about how we do localization at Babylon. Okay, my name's Dominic. I'm a full stack / front-end developer, and for the past couple of years I've been the main custodian of Babylon's federated graph. So for those of you who don't know Babylon, we are a health tech company, and our mission is to put an affordable and accessible health service into the hands of everyone on Earth. And Federation turned out to give us a way of solving this. And this is what I'm going to be talking to you about today. So for context, I'd just like to quickly show you a screen that we have. This is a screen in our native app, and you'll see some text, and we want all of this text to be localized. Now, this screen allows you to see where you're logged in and to log out if you want to. And the text at the top and the bottom of that screen are just normal text that's owned by the UI, and so that's really easy to localize. But the text in the middle is coming from the graph, and it also needs to be localized, and this is far more problematic. So this is the architecture that we were assuming we were going to need to have. So we have a consumer at the top, we have our router in the middle, which is receiving the GraphQL request, and then that's being routed to the domain subgraph. And the domain subgraph is now having to make requests to the localization service in order that it can return the localized strings that we want to return to the consumer. One of the things we also need to take care of when doing this is that we need a way of routing the localization preferences that the consumer has to the localization service. And this is needed because the localization service needs to return a localized string based on the needs of the consumer. And so we're having to shuttle that through. And we need to do that regardless of whether we are talking about implicit localization preferences, like HTTP's accept language header, or explicit preferences, like preferences provided via the GraphQL input parameter. So what if we had a localized string type instead? Well, in that case, we could have an architecture that looks more like this. And so what we've changed here is that instead of having a localization service, we now have a localization subgraph. And so we're no longer having the domain subgraph have this synchronous dependency on the localization service. Additionally, it's now possible for the localization subgraph to request the localization preferences directly from the consumer. So we're no longer having to shuttle the localization preferences through the domain subgraph. This has been really good because we have lots of domain subgraphs that needed to do localization, and so we don't need to have that synchronous dependency in any of those domain subgraphs. Additionally, it's good because if we want to handle service resiliency, we can now handle that in one place, in the router, rather than having to handle it in all of our domain subgraphs. Okay, so it's time to meet our localized string type. So I'm going to start by showing you a little bit of schema definition language for one of our domain subgraphs. And you'll see within the type user session that we have a field called device name of type localized string. So this is us using our localized string type. And just to make clear where that was used, this is the exact same field that we saw in the screenshot previously. Now in this example, the client isn't being explicit about their localization preferences. So we're essentially relying on the accept language header that the browser is sending via HTTP. All right, here's another query. It's pretty much the same as the one you saw before, but this time the client is being explicit about their localization preferences. So in this case, they want the language to be Spanish. Okay, so how does this work? Well, before I show you the actual implementation of the localized string type, I just want to do a quick recap on how entity types work in Apollo Federation. Okay, so here's an example of the fact that in Apollo Federation we have value types and entity types. And the way these differ is that with a value type, a subgraph just returns the data for that value type. But in the case of an entity type, when we're returning an entity object, a subgraph just returns the ID field, whatever that happens to be, or ID fields. And then it's the owning subgraph, whichever domain that owns that entity, that's the one that's responsible for using that ID field and going to the primary store, typically, grabbing the actual data and populating the data. And so that's how our entity types are working. So based on what we've seen, one thing we come to realize is that localized string is not actually an entity type. And so we don't know what to call this in Babylon, but the name we've used so far is we're calling these things utility types. And basically, for us, a utility type is an entity type, but where we misuse the key. And instead of using it to provide a key, we actually use it to provide arbitrary JSON config. Okay, so I want to come back to this picture and have a look at this pictorially. So now I've introduced a third new type, which is our utility type that you see on the right-hand side. And this is operating in a very similar way to the entity type. So a subgraph that wants to return a utility type is going to return the sort of constructor config for that utility type. And then the subgraph that owns the type is the one that's going to go and populate the actual data that we want to end up with. So that's how that's working. Okay, so now we know all of that, we can finally have a look at the definition of the localized string type. And what you'll notice at the top is that we have an @key directive. And with entity types in Apollo, the @key directive is how we identify which field or fields are the ID fields. And in this case, we're misusing it because the thing we're pointing to is this context field. And context is not an ID field. If you have a look, it says context of type localization context. And if you look further down, you'll see that localization context is actually a scalar. And the comment for that says JSON conforming to localized string server context. Okay, one more thing to show you now is that beneath the context field, we have a text field. And the text field is the one field here that's actually designed for public consumption. So the context field is something we don't want the consumer to actually see. And to deal with that, we use this @tag directive, which says that it's internal. And this relies on a feature called Apollo contracts. And if you haven't seen Apollo contracts before, it's a means by which you can add some tags to your schemas, and then you can define some filters. So they're either include filters or exclude filters. And it takes your supergraph schema and creates a new schema. And that new schema can be the one that's available for public consumption. So what localized string has allowed us to do is go from this architecture on the left to this architecture on the right. And we've said that there are benefits to doing this. Thank you.